Hi everyone, welcome back to the workshop, and it's repair time again, and this time something a little bit different. This is a PA amplifier, a 200 watt PA amp, 4 channel as you can see, individual low impedance microphone inputs and the 1/4 inch jack high impedance inputs. And over at the right hand side we've got a master equalizer here, bass, middle and treble, a master gain control for the entire amplifier, delay foot switch, send and return for effects, and a post output there. And interestingly, it's got a digital delay here because each channel has got a delay knob on it for adjusting the digital delay on each one of the inputs there. Now, as you can see, it's a little bit rusty on some of the screws, and that's because it has been used in an outdoor situation. It's been undercover in a barbecue area. Now, in the northeast of Scotland here, the weather is very changeable, and so it's not surprising some of the screws have started to rust there. And the owner of it just told me it just up and died. So first thing we're going to do is open it up and take a look inside. Now, looking at it, we've got 4 screws on the top side here, and I suspect that holds the internal chassis into this wooden case. So we'll take them out and it should slide straight out. Oh, what a job that was. This fabric that covers the wooden box basically just got in the way something terrible. So taking a look inside, we've got a large transformer over here. It is a 200 watt amplifier, and we've got the main amplifier board down here, and you can see bonded to the heatsink there are 2 large transistors. They're 15 amp NPN and a PNP there. And also we've got a thermal switch here, obviously for shutting down the AC input in the event that this heatsink here gets too hot. And down on the main board we've basically got the driver circuit. We've got a couple of large transistors here. Those are just a 6 amp, a TIP 141C and a 142C NPN and PNP there. So they're obviously driving these large transistors on the heatsink there. And it looks like we've got a couple of large resistors there as well. Those will be in series with the emitters probably on those main transistors there. And we've got a few other components, a capacitor there. We've got over at this end of the board, bridge rectifier there, 4 large diodes, they look like 5404s. We've got 2 large electrolytic capacitors there. That'll be for the unregulated supply, bridge rectified from the transformer there. And we've got 2 fuses as well. And taking a closer look, both those fuses are blown. So I'm beginning to think, before I even get the meter onto this circuit, we've probably got a short circuit somewhere. Perhaps the driver transistors or the main transistors maybe. And down in the middle here we've got a small board here. That's for the delay circuit, a PT2399. That's found in all over the place in the muso world, from guitar pedals to PA amplifiers for generating that digital delay. So first thing I'm going to do is I'm just going to put the meter on it. Let's check out some of the components. Let's see if we've got any short circuits and see if we can find out why those 2 fuses have blown. And over in the corner here I've got 2 TO220 packages up against the back panel there, and in the vicinity of these large electrolytics, I would suspect that's 2 regulators, possibly plus or minus 15 volts. So I think the first thing I'm going to do is just get the meter in. Let's take a look and see if we can find any dead shorts before I take this PCB out. Okay, so I'm just going to go around the board, got my meter set up, so let's just go across this large transistor on the back here. And on the base and collector, nope, that's fine. Base emitter, 101 ohms, that'll be okay. There's 2 resistors down on the board here. Those will be part of the circuit, so no problem there. And the collector emitter, Yep, that's alright. Onto the other large transistor. Base collector, that's okay. Base emitter, yeah, that's 100 ohms as well, that'll be fine. And the collector emitter, yeah, that's okay. And onto the two driver transistors here, the TIP 141. Collector emitter, that's okay. Base collector is okay, and the base emitter, yeah, that's fine. And on to the other one. Collector emitter, that's fine. Base emitter, that's fine. And base collector, that's fine as well. So no dead shorts on the transistors. Doesn't mean they're working, but it's the first step anyways. Next thing, how about the bridge rectifier? Well, let's get the meter into diode mode. And let's go across each one of the 4 diodes in turn. Yeah, 0.5 of a volt on that one. 0.5, other way around. 0.5. 0.5, so I suspect the bridge rectifier's okay as well. And there's that 2 regulators down there, well, assuming they're regulators. Can't get at the pins, but if I take off that small bracket that's clamping them to the back panel, I should be able to get to the pins. Now looking at those 2 components, they are indeed regulators. This one's a 7915, and I can't quite read that other one, but I'm fairly confident it's a 7815, a positive 15. And interestingly, if you can see, the negative 15 volt regulator has an insulating pad behind it to insulate it from the rear panel. But if you look at this other one, it doesn't have that. It's just got some heatsink compound behind it. So I wonder if that's a problem. So I will be looking to put something behind it, because I don't think that tab of that regulator should be bonded to the earth. Now it is the common for that regulator, so it's 0 volts on the circuit, but whether that should be insulated or bonded to earth, I'm not so sure, but certainly not through the tab of a regulator, so I'll fix that anyways. Well, the screws of this heatsink are actually quite loose, it's a little bit worrying. Well, that's the board loose anyways. Just cut this cable tie. There we go. Let's take a look at the back of the board. Well, it doesn't look to be in too bad condition. Certainly nothing burnt out. Nothing looks like it's been overheating at all. You can see the 2 large transistors there, the flux in and around those pins. So whilst I'm on the back here, I will go ahead and just resolder, refloat those pins on those transistors, and just make sure we've got no breaks at all. But the rest of it looks pretty good. I think somebody's been in here before. There's some flux round about this transistor here. That's one of the TIPs. But this one's okay, so maybe it's been repaired before at some point in its life. And I can smell that's definitely old solder that's on there. Now I did find one suspect joint that looks like somebody done a bit of a repair job on this track leading to this pin here, this through hole pin here. It looks like they'd scraped the track and then just flowed some solder off of that pin onto the track, so maybe there was a break on that track at one time. So I've just got a resistor leg and I'm just going to run it right along from end to end there. So just finishing it off now. And there we go. But the rest of it looks okay. Next to remove and replace are these two fuses here. Now they're just normal 20mm fuses, but they're actually soldered down. They've got legs on them, they're soldered down onto the PCB. So I'm going to try and see if I can replace those fuses with a couple of sockets for the normal 20mm fuses. Right, so let's get these fuses out. I'll take a look at the size of them once I can get them out. I don't have a schematic for this unit. Yep, that's the first one out. And it is fuse 2. And it is 5 amp. That's it out. And it is 5 amp also. And it looks like those two fuses are in series with the secondary windings of the transformer coming onto the board. Looks like you've got a centre tap there and the two outer secondary windings there through both fuses. And interestingly, the discoloration at this end of the board is on this leg here and this one here. And that is a series resistor with that positive volt regulator. So I wonder if that's just coincidence. Maybe the 15 volt supply draws more current than the negative 15. And also we've got some markings on the circuit board which will help me. Positive 40 volts and minus 40 volts. So we'll certainly be able to measure that. The next step is, because of that discoloration on that 7815, I think I'm going to pull both of those regulators and test them on the workbench. I don't really want to replace the fuses and power up and risk running it with perhaps two regulators or one regulator that's outputting the full 40 volts or whatever's feeding it. And the reason we've got two series resistors with the inputs to those two regulators is to drop the voltage down a bit. You can't really have positive 40 volts or minus 40 volts going into those standard 7815 and 7915 regulators. They're just going to get red hot. And they're probably only spec'd either 30 or 35 volts depending on the brand. So the resistor is to drop the voltage down a little. Okay, so I've got the regulator hooked up to my power supply just off screen, so I'll just turn it on, feeding it 20 volts, and let's just go onto the output here. Yep, 14.9, 15 volts, perfect, no problem there, so that regulator can go back onto the board. Right, now if you know your positive voltage regulators, the 781 series, you'll know that it's input, common, output. And on the 791 series, the negative voltage regulators, it's simply the middle pin and the left hand pin swapped over. So it is common input and the output's always at that right hand pin. So I've got minus 20 volts going in. So let's just measure the output. Yep, minus 15 volts. There's nothing wrong with those regulators, but it was a good test to make. So it's back to the fuses. So like I said, I do want to put fuse holders in, and I'm going to use these two here. Very, very common through hole fuse holders, 20mm. Now unfortunately, the legs of those original fuses, the hole in the PCB is not quite big enough for these quite wide pins on these fuse holders. So we'll need to drill them out. So I'm just going to use my little battery drill. So off we go. One. And there we go, that's the two fuse holders soldered in place. Perfect. Now I'm going to fit two fuses now, and I'm actually going to fit two slow blow fuses. Just the nature of it, those secondaries there, yeah, unlimited current sort of thing. I think we could benefit from two slow blows. Okay, we're nearly ready for a power up. I've got the circuit board just raised off the bottom of the enclosure there on a cardboard box. And I'm going to use this here, which I made some time ago, a light bulb in series with the live feed to the transformer. And if this has a short circuit or anything like that, rather than blow fuses and etc., it'll light up the light bulb. So let's try it out. Okay, all ready to go. There's a power switch on the back of the amplifier, so let's just switch it on and see what happens. And yes, we've got a faint glow there, meaning there is some current flowing on that primary side. That's good, and if you saw, there was a flash before it reduced intensity, so that was a surge running into the transformer. So let's try it again. Let everything dissipate and switch on. Yep, perfect. That's a 40-watt bulb and it's only just lit, so there's obviously very little power being consumed. So next thing is I want to check out the output from the amplifier. I don't have any load or any speakers connected right now, but I just want to put my meter across the output connections to see if there's any DC component on there. There shouldn't be. And also I want to check that plus and minus 15 volt. Right, got my voltmeter hooked up, so let's put power on again. And let's just check across that output there. That looks pretty good, a tiny little bias voltage there. And the other one, that's looking good as well, and it matches the other one. So now let's check the power supply. I think this is a ground connection here. Minus 32 volts on the unregulated side. Positive 32 volts, that looks good. How about the input to the regulator? Positive 20 and minus 27. I suspected that plus 15 volt side is drawing more current than the other side. And the regulated side, minus 15 and plus 15. Perfect. Now I don't have any speakers handy in the workshop, so I'm just going to hook up these two 100 watt 10 ohm resistors, one on each output, and I'll scope the output and see if what we're getting. Okay, I've got my two 10 ohm resistors hooked up to the output from the amplifier. I've still got my light bulb in series. I've got the scope hooked up across one of those outputs via my isolation transformer. So let's switch it on and let's see what happens. Okay, slightly more of a surge there, and I think that's because it was driving the load at the same time. And in fact, as I'm speaking, that light bulb's changing in intensity. So let me pick up the microphone. 1, 2, 1, 2, yes! And how about the scope? Yep, 1, 2, 1, 2, 20 volts per division. That seems to be doing something as well. Brilliant. So let me move it across to the other output now and see if it's doing the same. Let's switch it on. And the other output, 1, 2, 1, 2. Yes, that's doing as expected as well. Brilliant. So I'll turn power off. And what I'll do now is I'm going to bypass the light bulb so that I'm getting the full 240 volts on the input to that primary. And switch on the amplifier. Yep. 1, 2, 1, 2. Yep, that's working. Okay, for the next test, I've still got the microphone hooked up, but I've got my iPhone playing tones into the microphone. So we'll start off with a 500 Hertz tone. So let me just hit play. It's kind of warbled effect, I can hear it, and you can see that on the scope there. So that channel's okay, so let me move it across to the other one whilst it's playing. Yep, and that's the same. Perfect. And there's 1000 Hertz. Well, I think we're ready to box it back up, and then I can turn it round and play with some of the controls in the front. Okay, so I've got it turned round now, all bolted back up inside. So let's just check the input. Power is on, master's right down. I've got a power LED there, so that's good. Let me just turn up the master volume, 1212. Yep, that seems to be working on the scope there. And the channel volume control, yep, that's no problem at all. So I'll just go along the line and see if all 4 channels are working. 1 2 1 2, yep, that's fine, perfect. 1 2 1 2 1 2 3 4, yep. And this one 1 2 3 4, yep, no problem whatsoever. So let's try the EQ. If I turn the EQ right up there and turn off all the bass, 1 2 1 2, and put on some treble, you can see I've got a lot of high frequencies there. Yep, so the EQ is working. So I'll put them all back to 12 o'clock. And let's just see what this delay does. 1 1. Well, without delay, I don't know if you can see that. As soon as I stop talking, it more or less flat lines immediately. 1 1. If I turn the delay right up, 1 1. Yep, you can see the delay there. So short of putting a speaker on the amplifier, I can't really test it much further. Well, there we go. It appears to be repaired. Of course, the proof in the pudding will come when my friend hooks it up in his back garden barbecue area and gives it a run for his money. But I'm quite sure it'll be okay. What caused the fuses to go? Well, it could have just been a surge. It could have been maybe shorted out some of the speaker outputs, although I'm assured he didn't do that. Or whether it was just that regulator in the back that didn't have the insulating kit fitted and it caused a problem. I don't know. All I know is it appears to be working now, but needs to be run at full load to make sure it's okay. So thanks for watching, and remember you can always comment down below, and don't forget to like and subscribe. It really does help the channel grow. There's plenty more repair videos on my channel, from the simple to the complex. Check them out, and thanks for watching.